Okay, so today you're going to be listening to the PowerPoint as I present it, and then following along with the notes that you were given and filling them in. So it's just like when I'm here in class, only you're going to try to do it without me actually being in front of the room. So today we're talking about the scientific revolution. There we go. Scientific revolution is a new way of thinking about the physical universe. So where it says scientific revolution equals, it's a new way of thinking about the physical universe. It's a change in the way that people think. So if you think about how when we learned about the Renaissance and humanism and thinking about oneself and bettering oneself, this is another similar, we're going to change the way that we look at the world. Only instead of looking at it through art and humanities, we're going to start looking through it in a scientific way. Okay? Mathematic laws are going to govern nature and the universe. The question is, the universe can be managed and shaped by the people. Okay, so the scientific revolution is the final break from Europe's medieval past. That's going to be where it says number 2 on your notes. You're going to put number 2, where it says number 2, it's the final break from Europe's medieval past. So we are officially into this new, more modern time. 15 to 1600, people began to question the views of Ptolemy and Aristotle and those views that were supported by the church. So again, it's another way to challenge the church. And you can even see that in society today, how people use science often to challenge the church. Now, again, the final break from medieval's past will go right where your notes say number 2, and then 1500 to 1600 is going to be number 3 there on your notes. So you should have that first little section filled out. So now we're going to talk about the people who are the leaders of the scientific revolution. So, Nicholas Copernicus, he creates the idea of a heliocentric, sun-centered model of the universe. So basically that the sun is in the center and all of the planets rotate around it, that's what you learn in science. This idea is created by him. And so that's going to be right next to his name. And then again, this will be your number 1, and this will be your number 2. Planets revolve around the sun. Again, what you learn in science today. And he proved that Braun and Kepler, was proved by Braun and Kepler, and determined that the orbit was in the shape of an ellipse. So oftentimes, before they knew, they thought it was a perfect circle, but now they know it's more of like an ellipse shape. So think about it, how sometimes the Earth is closer to the sun during some seasons and then further away, which would be different if it was all in one circle, right? Because if it was all in one circle, then we would always be the same distance. But this ellipse, you can be further out or closer to the sun, depending on where you are in the Earth's rotation. All right? The next person is Galileo Galilei. Now, hopefully, I think Galileo is someone you hear about a little bit more often in science. But Galileo discovers the moon orbiting around Jupiter and verifies that everything does not revolve around the sun. So this idea on Earth that every moon or planet is orbiting around the sun gets disproven by Galileo when they discover that the moon actually is rotating around Jupiter. So the sun, though it's the center of the universe, is not necessarily the only thing that is having things revolve around it. And this is he's going to be charged with heresy, which basically means going against the church, and kept under house arrest. So though he's correct, when he discovers this, he's going to actually be put under house arrest for going against other church or main beliefs. So it's kind of crazy to think about this concept that, okay, he knows, he's actually right, and he got punished for being right. Because people during this time period don't necessarily like change, don't necessarily like their beliefs being challenged, and if it's something that's unknown, it might sound crazy to some people. And I think that's important even in society today when we come across something that, well, that can't be, that's not what we always do. Sometimes it actually maybe is, and we just don't know yet. Another kind of interesting point of view or something to look at there. Okay, so you should be about halfway through with your notes. Hopefully you're being able to follow along pretty easily. These are supposed to be pretty straightforward. And hopefully some of this maybe sounds familiar from science class, kind of crossing over into the scientific territory here as well. All right. You should have said that they both argue that truth is known at the end. That was going to be argued about. They both argued that truth is not known at the beginning of an inquiry or question, so that's a question, but at the end. So basically saying that we are not going to know the actual truth or the facts right when you present a question or present an idea, but at the end. So think about like a scientific experiment, right? Like you come up with a hypothesis, and then you test it, and then you look at your data, and then at the end you have the answer. Now, that's going to be more so how Bacon looks at it, and then Descartes is going to look at it a little differently. But they're both talking about the idea that you can't just come up with a question and have an answer right away. You have to go through a process. And so they both believe that. They just believe that you reach that process in a different way. So Bacon stresses the idea that you have to go through a series of observation and experimentation. So when you do like a lab in science, you come up with you have a question, you make a hypothesis, you perform a different task, you observe what you experiment, you observe what happens, you write down the data, and then you come to a truth. So this is more what you see in science. You probably can't even read that. Science. Let's try this again. This is more like science class. Okay, with that hypothesis and your process and all of those different things. Descartes emphasizes human reasoning, that you come up with a question and then you use human thought process to decipher and decide what the truth is. So you have more of an observation experimentation with Bacon and more of a thought, human resource reasoning, and the use of knowledge with Descartes. So you need to know the difference between the two and what they both believe, but be able to differentiate between the two. All right? All right, so the next thing should sound... so here we are at the scientific method. And the scientific... Okay, so we should be clear with that. Discovery, where you first state a problem, then you gather the information, then you form a hypothesis, then you experiment, then you collect, record, and analyze, draw a conclusion, communicate, and share data. Now, these need to be in your notes in order because it is a step process. You're not going to necessarily collect and record data before you state a problem. So you need to know that and understand that method. Now, this is something that you go over, I'm sure, in science when you do labs and things like that. So it should be a pretty clear, familiar idea. But again, this is going to come up during this time period. Moving into medicine and chemistry, during this time period, medicine and chemistry is going to be rated. Now, remember, we're talking about mostly in the Europe continent. Think about it. Where have we heard about large advancements in the past of medicine and chemistry before? It's just now getting to Europe in the early 1600s, but where was it striving before it gets to Europe? Okay, the answer there is China. So the Asian continent, we learned about ancient China and how they were doing advancements during there. And those advancements are eventually going to come over into Europe. And during this time, we're going to get the study of human anatomy, which is going to be your number, your number 1. And then where it says number 2, you're going to put the discovery of individual elements and components. Now, these are just examples that I listed for your information. You don't have to write them down. You don't necessarily need to know that, but for your information. So studying human anatomy, that's the human body. This is when the first time when we're going to get autopsies. Autopsies are going to be where we examine a body after a person has deceased to discover how they died or what sicknesses they had or study those sicknesses. They're going to learn how to prevent infection, some new surgical techniques, artificial limbs are going to start to come out, very basic level. But think about it. If they know how the body's working, It's going to be a lot easier to perform surgical techniques. So advancements in medicine, circulation of blood. They learn that the heart is actually what pumps your blood. And they use a microscope to see the first human cell. Now you can imagine how much this is going to change a lifestyle. Now think about it for a second, maybe one or two reasons how this could change humans' life. Now, I'm sure you came up with a bunch of reasons. I think one is probably going to be lifespan in general, because people aren't going to be getting sick, and they're also going to have ways to fix those illnesses or cure those illnesses. The second one is those discovery of individual elements in chemical compounds. So think of that periodic table, which I'm sure you all love so much. That's going to kind of start getting developed here. They're going to learn that different elements are affected differently by temperature and pressure, and going to help to create even more advancements in science that way. The last one to talk about is good old Isaac Newton. How many of you have heard of, guy sits under a tree, the apple falls down from the tree, oh, it's gravity. Okay, that's the story we learned when we were younger. But basically, Isaac Newton discovers gravity, that it's the single force that keeps planets in orbit. So there's this one force of gravity. It's what keeps all of us, our planets, circulating on that ellipse around the sun. Now, Newton comes up with laws. He actually has a series of 3 laws, which you're going to go over in just 1 minute when you're finished with this. That for every action, there is an equal and opposite reaction. So if one thing falls, everything goes equal and opposite of that. Okay, so your notes should now be complete. They were one-sided. Hopefully this wasn't too bad and it was easy to follow along with. Your task now is going to be to go into Schoology. There's a series of documents under the Revolution folder. It says Scientific Revolution. There's a series of documents. It's very similar to the middle passage assignment that we did a couple weeks ago. You're going to look at a series of documents. Each document is going to have a question on the document answer sheet that you were handed. You're going to answer each question in the appropriate box. Keep your notes when you're done. Turn in the Scientific Revolution questions. Okay? And this is all we're going to be doing on the Scientific Revolution. And then tomorrow we're moving right into the Enlightenment. Alrighty. I will see you later.